Welcome to NASA Edge's live coverage of the Cygnus launch from Hangar AE at Cape Canaveral Air Force Station here in Florida. Again, we have a very busy schedule because Mike Freilich, our first guest, is on console. Thanks for taking time out of your schedule to give us an update on things.
Well, thank you, Blair. It's my pleasure.
What exactly is Cygnus, and how does it fit into NASA's overall goals for the Science Directorate?
So Cygnus is a very interesting mission involving the launch of 8 microsatellites in a tropical orbit. They will provide incredible, unique measurements of wind speed and air-sea interactions in the developing and dynamically important eye walls of hurricanes and tropical storms. So this mission, with its 8 small satellites and very frequent measurements, will really help to revolutionize our ability to predict hurricane intensity as well as hurricane track. This is one aspect of many that we attack in the Earth Science division, where really what we're trying to do is to understand the Earth as an integrated system and to take that understanding, which is based on measurements from space, in order to develop applications and deliver societal benefit.
Well, now, speaking of that benefit, talk a little bit about the scope of what NASA can do once this data is acquired.
First of all, let me make very clear, Blair, that all of our Earth observing data that we acquire in NASA is made freely and openly available to anyone in the nation, anyone in the world. In fact, there is no period of exclusive use by the scientists who conceived and designed of the mission. And Cygnus data and the conclusions from the Cygnus science team's analysis will be broadly distributed. It will be used by operational meteorological and hurricane forecasting organizations in order to fairly rapidly improve our ability to protect life and property through more accurate forecasts.
So, Mick, ordinarily you're on our show during the live webcast and talking us through some of the processing of the spacecraft, but this time you're not on our live show because you have a different role for this mission. Tell us what it is.
Yeah, for this mission, I'm going to be serving as a vehicle systems engineer, leading the LSP engineering team. We'll be processing the vehicle, looking at the vehicle during flight, making sure everything's ready to go, so we can give the NASA launch manager a go for flight when it's time.
Will you actually be on console?
We'll actually be on console, leading that team, conversing with the team, and getting all our feedback so we can provide that up to the management chain and the launch director for ready to go.
Awesome. Now, I understand that this is a unique mission, obviously, but tell us a little bit from Launch Services' perspective. What is processing of this kind of rocket? What's involved in that process?
So yeah, unique air launcher that Orbital ATK provides. One of the things that's great for us in Launch Services program is we actually work on both coasts of the United States. The vehicle's processed in Vandenberg Air Force Station, so we do a lot of our work out there in flight sims and testing, and then we ferry the vehicle back here to the Cape for final processing and getting ready for launch day. Once we get the vehicle here to the Cape, we'll do some final testing, what we call combined systems test, to verify everything is ready to go for the day of launch. On ferry day from Vandenberg to the Cape, the Launch Service Program will have a team in Vandenberg looking at all the data as we fly out over the horizon, making sure the vehicle is in a good health status, and the computer and the CYGI, which is our inertial navigation unit.
CYGI, I hadn't heard that before. Okay.
CYGI, inertial nav unit, is in good processing, ready to go. And then we'll also have a team here at the Cape for when we fly the vehicle in. And we will actually fly through the area of the Cape to make sure everything's good and that we're picking up our signals with the range assets here on the Cape side, and we'll verify that health status again with the inertial nav unit and the flight computer prior to landing and getting ready for our final testing before launch day.
So from a launch services perspective, what goes into deciding that you're actually going to use a Pegasus rocket for a particular mission?
As we've talked on your show before, Launch Service Program has a wide variety of fleets to choose from. Pegasus is what we call our small class vehicle.
My class?
Yeah, your class. That gives us an opportunity to work with universities and smaller satellites for science opportunities. Cygnus is actually launching here out of the Cape, which is we're very happy about. but it's the first time that we've launched a Pegasus out of Cape in 13 years since the Galax mission, which Launch Services Program was part of. And we're very excited for that. Matter of fact, our next mission is the Icon mission, and we'll be taking the Pegasus system to the Kwajalein Atoll to launch that in 2017. So we're very excited to be partnering with Orbital ATK and the Pegasus system again.
That's awesome. I'm sure it'll be a successful launch.
We are looking forward to it.
I'm Rachel Power with NASA's Digital Learning Network, and I have here with me today John Shearer, who is the Cygnus Program Manager. Welcome, John.
Thank you. Hi.
So one of the challenges with this launch, of course, is you're flying an airplane that's holding a rocket, but there's a purpose for launching in this way. Why do we have the Cygnus spacecraft on board Pegasus? What's the reasoning for that?
So Pegasus is basically a perfect fit for Cygnus. We are, a fairly small flight segment. We're lightweight, and Pegasus is a relatively low-cost, inexpensive launch vehicle. And so it fits within the Earth Ventures program pretty much basically is tailor-made for it.
In terms of this project, how it works, I know you're sitting on console right now this morning. So
Yes.
as we progress through the morning and we get to taxi and takeoff, what exactly does that mean, to be sitting on console? What are you guys doing on console?
Yeah, so we have this 100-page checklist that we walk through, and basically it goes through the whole checklist. Before right now we're about to have engine start for the plane, then we'll taxi, and then we'll ultimately drop the Pegasus and ignite.
So once that ignition happens and Pegasus does in fact launch, what happens from that point forward?
Yeah, so after ignition, it's about 13 minutes to the separation of each of the microsatellites. They separate from the deployment module, which stays attached to the third stage of the Pegasus, and they separate in opposing pairs, and there's 30 seconds between each of the separations. When they separate, we have what we call break wires, and it turns on each of the microsats. They come alive, turn on their computers and all that kind of stuff. Our commissioning period is actually 60 days. The first 30 days is commissioning of the spacecraft, making sure that all the systems are working as expected. Then we transition into bringing up the instrument and going through a calibration and validation period of 30 days. And that's then when we actually start getting what I would say scientific data.
We're here with Ed Dunlap, who's the Senior Program Manager for Orbital ATK's L1011 Stargazer, and we're actually in the simulation facility here today. One of the things that we're wondering when we think about this operation of actually dropping a rocket from a plane and launching it into space is, what is the simulation process all about? What are your goals and objectives to get ready for that kind of event?
Yeah, no, it's a good question, and it is a complex operation because it is an air launch, so it's quite different than a standard ground-based launch. There's actually several aspects to getting ready for the launch. One aspect is the airplane itself. We've got to make sure that all of the maintenance program and requirements on the aircraft are met and up to date. And then for every launch, there's usually specific customized modifications. So we work with the Pegasus team of engineers in Dulles, in Chandler, and at Vandenberg to go ahead and make sure that those modifications are complete so that when we're ready to launch, it's all done. Another aspect of my job is to make sure that the flight crew is ready. And so that's what we're doing here in the simulation building. We're fortunate to have worked with a company here that has other simulators, and we have our own L1011 simulator. Like the airplane, this is the only other one operating in the world. But we're able to use that simulator not only to keep our crews current, but also to put in the profile that we'll use for each specific launch and allow the pilots the opportunity to actually practice that in the simulator before we go out and launch. And the third aspect of preparation for launch is facilities. In order to mate the rocket, we actually have to jack the aircraft. So we have some equipment that we have to send there and make sure that it's all ready and set up. And then we also have to set the facility up at, in this particular case, in Florida at Cape Canaveral. And that requires some coordination because of potentials of lightning strike there. So there's specific things we have to do to make the ramp ready for the operation. So all of those things require a lot of advanced coordination to make sure that everything is set and ready.
Sure, and in a place like this today where you actually have a simulator, you go through, I guess, like you said, the flight profile for Kennedy, even though you're here on the West Coast.
That's right.
You've got to be ready for any given circumstance for a launch.
That's correct. And that's the great thing about having the simulator is we can program in waypoints and coordinates for whatever location, simulate we're in that location, and the pilots can fly it just as if they're in that location.
How do you progress through the ranks to become a pilot, or is even at the goal What is the purpose of the simulation, and what really qualifies for now being flight ready for a Pegasus mission?
Well, because we do launch relatively infrequently, whenever we do go on a launch, we take extra crewmen because we want them to be in the cockpit. We're fortunate enough the 1011 has a very large cockpit. There's a couple of extra jump seats or crew seats that are in there. And so they can go along and observe. So we never have anyone who goes along a launch that this is the first time they've been in the cockpit on one. All of our flight crew are highly experienced, captain qualified, no matter what seat they're in. We also have, again, this is an older legacy aircraft, so it has a third position we call a flight engineer. And they're also there as an extra set of eyes, part of the communication process for a launch. So all of them have been through this numerous times before they ever get into the front seat to do a launch. Most of our guys came, obviously, if you've got a lot of hours in an airplane like this, it's usually because you work for the airlines. And so most of our guys came from the airlines, but we do have some that work for Lockheed originally, that were production test pilots. Fortunately, with the simulator, we could bring in someone who may have been qualified on another airline type, large aircraft, and get them up to speed on our aircraft. And again, the simulator really allows for that because obviously the cost of operating the simulator versus the cost of flying an airplane, that was designed to carry 300 people, uses a lot of fuel. So this is an excellent tool.
So for this simulator, do you have to construct it uniquely for the purposes of Stargazer, or how does that work?
Well, simulators were designed for primarily airlines to use to keep their flight crews current. And for many years, we rented space from TWA or Delta, who had those. When those airlines quit using the airplane, we were able to obtain a simulator from them. So it's really an airline simulator. The good part is that this particular one is in the same configuration as our L1011. There were various types of L1011, some designed for long range, shorter fuselages and things like that help them with long range. This one's exactly like ours. So from a performance standpoint, it's very similar. In terms of preparing for Pegasus, we haven't really made any changes to it. There are some things that we might be able to do and that we're looking into doing, but none of them are really substantive that would really help the crew any more than just being able to use it to practice the launch.
I'm joined on the set right now by Mr. Justin Treptow from the Launch Services Program. And Justin is here today to talk to us about an app. But before we get to the app, Justin, tell us a little bit about what you do with LSP.
Right, so I am with the Trajectory Design Group at Launch Services Program, which means that everyone in my group deals with the trajectories that the rockets fly. So whether it's a ULA vehicle or a SpaceX, or in today's case, Orbital Space Sciences, ATK, Pegasus mission, we deal with finding the optimum path for that rocket to fly on.
The app that we're going to be talking about today is called Spacecraft 3D.
Yes.
Tell us a little bit about Spacecraft 3D and how you got involved with it.
So Spacecraft 3D is a spin-off app from a group at JPL. They do a bunch of visualization projects. And what this is it's a mobile device app for an iPad or an iPhone or Android device. And it lets you hold a spacecraft or a rover, or in our case, a rocket, in your hand. And it sounds really, the description of it doesn't quite do it justice. You have to kind of see it to understand.
Okay, well, let's get to the app. I think Blair has the iPad right off set here, and he's going to bring it in, and we'll get a little demonstration of how this actually works.
So at the launch screen, this is the Spacecraft 3D main site. You step through, and it's broken out into a variety of different categories. The newest one down here in purple is Launch Earth's Bridge to Space, which is LSP's tagline. Mm-hmm. And within that, we have a bunch of different rockets. The one we're highlighting today is the Pegasus XL. And what it brings up is a view of the camera. You can see my hand in front right here. And we have these augmented reality targets that we've printed ahead of time. You can get them in card form, or you can just go ahead and print them from the internet. You just Google Spacecraft 3D AR target. And as soon as we get this to launch, there we go. As soon as we get that to pull up, recognize the target, and we have the Pegasus sitting here on the table.
Oh, that's nice.
And the scale, because this target is so large, our overall vehicle is really big too. We have to even zoom back a little bit to see the whole thing. The wireframe is the L1011, and underneath you see the Pegasus that we're going to be launching today. One of the really cool things is that we have different animations with all of our rockets. So we're going to stage our way through it, and we can see as the Pegasus drops off the aircraft.
Oh, it's just, that's
awesome.
That is. It's just,
You got a little shadow there.
It does,
It's
yeah.
pretty fantastic. They did an excellent job rendering these guys out. After the rocket drops off the vehicle, the first stage ignites, which is this entire back section. Let me just right through there.
Awesome.
We stage on, that falls away. Move on your second stage. The payload fairing opens, revealing a spacecraft inside. This one doesn't happen to have the Cygnus vehicle on top, but it's a previous mission that LSP flew. And then our third stage rocket. And what this really does a great job of showing is just the size difference between what is actually launched into orbit and the original thing. So you see right now how big the spacecraft is, and you can kind of get a little perspective, which is where the cool part comes in.
And you can scale that up and down, right? Can't you?
Absolutely. So again, that perspective comes in handy. We can scale all the way up and make sure we got a nice view of that rocket.
Oh, dude, that's crazy.
Moving
Yeah.
through it again.
Nice.
And you can
Dangerously large.
really get some cool stuff to see. And if you were really curious, you go to manual mode and you can zoom in here, move it around yourself, and then pop it back on top of the card afterwards.
Justin, this is awesome. Thanks for showing us this app today. I'm sure people are on their way to download it right now. Make sure you can run over to the App Store, or is it on Android and for the iPhone, and absolutely pick that up.
So Don, you're a pilot for the Elton 11 Stargazer, and you're actually flying the Cygnus mission. Is that correct?
That's correct. I'm the pilot for the Cygnus mission, but I'm supported by a lot of people.
So how many of these missions, these Pegasus missions, have you flown on, or have you been a pilot on?
I've been the captain on the past 2 missions. I flew 2 as a co-pilot and 1 or 2 as an observer prior to the Cygnus mission.
So tell us a little bit about what happens from your standpoint, fly up and get in position and actually launch a Pegasus rocket.
Well, it's pretty exciting to start with. The successful launch is basically a lot of normal procedures planning and a lot of planning for any of the contingencies that can happen prior to the launch. We spend a lot of time flight planning on the ground. Day of the mission, we load actual conditions for Cape Canaveral or down on the equator, wherever we are. And from the time when the aircraft actually starts rolling down the runway, it's a fairly scripted procedure. So someone in orbital, the scientists, calculate exactly the time when the Earth will be in the correct position for us to launch. And my job is to have the airplane at the right altitude, at the right speed, at the right heading, at the right time. So occasionally the launch windows can vary from as short as 5 minutes, where we have to have the airplane exactly at the launch point with plus or minus the 5 minutes. On the Cygnus launch, we have a 2-hour window, which gives us a unique opportunity to fly the pattern twice if we need to.
What are the kinds of things that can happen once you're aloft that may actually cause you to not be able to launch on that first attempt?
Okay, so there is a very detailed checklist that we proceed through from actually hours before we leave the runway, even before we start engines, until the time when we launch. And there's a very long script that involves all the players. We have launch parameters for weather, for the aircraft, for the rocket, for the range. And there are systems, people monitoring all of those systems on a real-time basis. So when a problem occurs, and it may, that exceeds one of our launch parameters, if it's an aircraft-related issue, it's up to me and to the launch conductor to determine whether it will affect the safety of the launch or the effectiveness of the launch. If it's something to do with the satellite or the rocket itself, then it's up to the launch conductor to tell us launch or don't launch.
Now, do you go through those parameters in the simulator as well?
We go through the parameters that affect us and the flight of the aircraft. So, for example, as we get toward the last 4 minutes of the clock are critical for us, and there's a lot of things that happen in sequence on a script. And if one of those things doesn't happen and the launch is aborted, okay, we go through a securing the rocket checklist to make sure that everything is safe. And then on the ground, they'll make a decision. Is the problem resolvable? Can they look at the constraint and see, given enough time, can we work around it? In which case, we'll come back around again and attempt one more launch. Or If it's a problem that has occurred that they need to do some maintenance on the ground, we just bring the rocket back.
Now, when you're flying the plane, it's a big plane and you've got this super huge rocket underneath. What happens once separation occurs? Because I imagine, part of you wants to see the launch, but another part of you needs to maybe get to a safer area. Tell us about that.
Well, that's true. And so in aviation, we have a rule that no matter how interesting something is, somebody always flies the airplane, in which case it's me. The laws of physics work in an interesting way. It's not very often that an airplane releases 52,000 pounds all at once. So the forces that work on an airplane in flight at the moment we're releasing the airplane is lift and gravity. So what happens is the lift overcomes the gravity. We weigh a lot less, so we go up and the rocket starts falling down and we separate by several thousand feet. The rocket will free fall for 5 to 7 seconds before it actually lights off. And as long as its safety parameters are met, the rocket lights off, and it's pretty exciting to watch it accelerate out ahead of us and then climb up into space.
Franklin, before we go to NASA's commentary coverage for the Cygnus launch, just want to thank a bunch of the people that helped make our show possible this week. First, KSC TV, providing us a lot of support. Also, Lee Erickson at NASA Marshall, who's flipping the switches, making sure everything's live. And then, of course, the team here at Hangar AE that made this location possible. Thanks so much to everybody. Continue watching coverage of the Cygnus launch. You're watching NASA Edge.
An inside and outside look at all things NASA.
LC, PLT, copy.
LC Peg, Peg is go for launch.
PLT, LC is go for launch. PLT confirm.
LC, PLT, PLT confirms go for launch.
Drop on my mark. 3, 2,
1. Go for release.
Pegasus is away.
And drop. Pegasus is away. Ignition of the Pegasus rocket with Cygnus, helping hurricane forecasters understand and predict the intensity of hurricanes.
Fin actuator system is working properly to control the flight of the vehicle during stage 1.
NASA 3.14159, you're cleared for takeoff.
NASA Pi, roger.
Huh?
Contact departure control.
Roger.
Huh? Request vector clearance, over.
What?
Your vector is 270.
We have clearance.
Roger, roger. What's our vector, Victor?
Tower radio clearance, over.
That's clearance, over. Over.
Roger. Huh? Roger, over.
What? Huh? Who?